today's class, in today's class, we are going to discuss as a part of municipal and industrial wastewater engineering, where we are discussing about treating of industrial wastewater. In previous class, we discussed about volume reduction, strength reduction. Now we'll discuss on treating wastewater by method of neutralization. This is a simple method where the excessively acid or alkaline waste should not be discharged directly into the stream. It has to be treated before discharging, else it is going to affect by high pH, low pH of effluent on water bodies. So here the alkali or acid are going to be neutralized by other substance, like if the industrial wastewater is excessively in acid, it is going to be added by an alkali so that get neutralized, else alkali is going to be added by an acid to get neutralized. So in this method we are going to neutralize the industrial effluent. Let's discuss method of neutralization. The mixing waste so that net effect is nearer to neutral pH. As I mentioned earlier, if some plant is going to discharge effluent of higher acidic nature, is going to be added by another industry which is going to have higher alkaline nature effluent. By this way, both the industries will get benefited by neutralizing an acid or a base. Single plant operation means acid or alkali waste may be produced individually within one plant. Proper mixing of this waste at appropriate time or between neighboring plants. So ultimately we are interested to neutralizing an acid or base. Example, a building material plant producing an alkali, that is lime or magnesia. The waste pumps the slurry after some equalization. Mix with the effluent from the chemical plant producing an acid waste. The neutralized waste resulting from this combination is more readily treatable for final disposal, and both plants thus solve the problems in economics, politics and engineering. So by simple means the problem will be solved. Let's say water can be used for any other process like reuse or recycle. How are we going to remove an acidic solution? One of the methods is passing the acid waste through beds of limestone. Passing an acid to the beds of limestone was one of the original methods of neutralizing them. The neutralization takes place according to the following reaction. Like if compound having a calcium carbonate is going to mix up with hydrogen sulfuric acid, going to get calcium supplies, and hydrogen carbonate, or we can say any bicarbonate compound H2CO3. The reaction will continue as long as excess limestone is available and in a active state. It's a simple method where we are interested to reduce alkali or acidic waste. In second method means mixing acid waste with limestone slurries or dolomite lime slurries is an effective procedure for neutralization. Similar to above method, even though it is slow acting, limestone possesses a high neutralizing power and its action can be quickened by heating or by oxygenating in the nature. Here is actively improved by heating or giving oxygenation the mixture. By means of that, the reaction will be little faster. And other one method is the adding concentrated solution of caustic soda to acid waste. These neutralizers are more powerful than limestone or lime. The advantage is that the reaction products are soluble and easily suitable for small volume. So this is very powerful. Like sodium hydroxide or sodium carbonate is very effective in neutralizing an acid. Other method is blowing waste boiler flue gas to the alkaline waste. Blowing waste boiler flue gas to alkaline waste is relatively new alkaline method for neutralizing them. Right here in this method, a gas of carbon dioxide is going to pass. When going to pass this carbon dioxide, it is going to be form reaction with acidic solution to form the bicarbonate or sorry carbonic acid solution. Instead of the caustic soda or slime slurry, here you're going to pass the gas. So well burnt or completely burnt stack gas containing approximately 14% of carbon dioxide. The carbon dioxide dissolves in wastewater will form carbonic acid, which in turn reacts with caustic waste or alkaline waste to neutralize. The excessive alkalinity is we discussed. So in this, by passing the carbon dioxide is one of the modified method where effluent from the industry who is releasing carbon dioxide is going to be reused. So air pollution also get reduced. CO2 is going to pass through this alkaline solution. Adding this carbon dioxide to alkaline waste, it neutralizes the alkali waste and the same principle as a boiler flue gas, but much less operating difficulty. That is here directly we are going to pass CO2 gas. How we are going to producing CO2 in alkaline waste? How we that burning gas underwater called a submerged combustion condition. Other one is adding sulfuric acid to alkaline waste. Already I have discussed in sulfuric acid is calcium sulfate plus H2CO3. Addition of sulfuric acid to alkali waste is fairly common but is rather expensive since the production of sulfuric acid itself is a very costly and also The storage of this sulfuric acid and to the feeding equipment require the more amount of equipment are low as a result of its great acidity but difficult to handle because of its corrosiveness. As you know, sulfuric acid is a very strong oxidation agent which is very corrosive in nature. So this method is a bit dangerous in the sense handling is a very problematic here, and also it is very corrosive in nature. By how it is storing and feeding to the equipment, it's a result of great acidity but difficult to handle. So these are the some of the ways we can able to reduce the alkali or acidic waste. In simpler way, we can say it is going to be neutralized, like by adding an acid or alkaline waste from the any irrespective industries. So the pollutant problem will be get solved for the both of the industries. It's a common solution for the both the industries. It's very simple method as I discussed earlier by passing an acid or a waste alkali solution, then you're going to supply carbon dioxide from the in the effluent, or you're going to producing CO2 in a alkaline waste. Let us discuss some of the MCQs. A equalizer's tank can be designed for equalization of is a volume and strength are both. So in equalization tank, the main purpose is to maintain the strength as well as the required volume has to be supplied. The flow equalization is nothing but you are going to maintain physical treatment, secondary treatment, tertiary or chemical treatment. The flow equalization is going to give physical treatment where we are going to maintain the discharge to the next process. Equalization is very useful for avoidance of shock load to biological treatment or improving uniform characteristics wastewater, improving the performance of ETP. It is going to perform in all the aspects. It is one is to break up the sudden shocking load or uniform characteristics of water so that performance will maintain in maybe in biological treatment where you're going to have a uniform characteristics of BOD, you're going to maintain higher efficiency so that if characteristics of inflow is going to be vary, it is going to be affected. The other one is proportioning is a type of unit operation where you are going to it's a physical process. The size of the equalization tank needed for offline equalization is more, less, same, none of this. The size of this equalization tank needed offline equalization is more because it depending on the volume of the treatment process or volume of wastewater is going to be discharged. The graphical method is a useful to determine equalization tank its aeration need, volume and strength both strength. This here you are going to get the volume of the equalization tank. The neutralization of wastewater is desirable to enhance the compatibility of wastewater for further treatment, prevent corrosion, corrode microorganism biological treatment, all of this. So here neutralization is desirable for all the purpose. That is compatible with wastewater, preventing corrosion. It is alkali higher in alkali and acidic in nature. Protect the microorganism in biological treatment. The lime slurry treatment is used to neutralization of is a acidic water. The treatment with flue gas is neutralization of acidic, alkaline, acidic, alkaline, both are none of this. You see, as I mentioned earlier, the wastewater containing alkaline, when CO2 flue gas is passes through that, it will convert it into carbonic acid. Lastly, the treatment of carbon dioxide is used for neutralization of alkaline water, similar to as I explained earlier. Okay, thank you.